Yeah, okay, looking at resisted motion, we're going to look at when something is falling down and what the terminal velocity is. Now, the terminal velocity is actually when the particle will reach its maximum velocity or its maximum speed. Now, that will happen when the acceleration is zero, because the maximum will always occur when the acceleration equals zero. If you have x in terms of t, then if you make time go to, v in terms of time, if you make time go to infinity, the velocity that it approach will also be your terminal velocity. And this will often happen like if you've got like a v equals something like, with a b plus a e to the minus kt in it or something like that. And as time goes to infinity, the e minus kt part, that goes towards zero. And the terminal velocity just ends up being the b, because that's the value that it approaches. Okay, so a particle of mass m falls vertically through a resistive median, and the resisted force that's acting on it is mkv squared. The particle has a terminal velocity of vt. Show that x equals 1 on 2k ln that, and da-da-da-da-da. Okay, so let's have a go at this. All right, so let's start with it. It's coming from there, so it's going to be dropped. So v is 0, x is 0, and t is 0. And when it reaches here, okay, it's it's got v is 0, x is 0, t is 0. That's all your initial things. When it's going down, plus is down and minus is back up. The weight mg is definitely a force, and that's positive. The resisted force will go in the opposite direction, and it'll be mkv squared. So the sum of the forces is minus mkv squared plus mg, and the mass times acceleration will equal minus mkv squared plus mg. If you cancel the m out, you get minus kv squared plus g. So that means that the acceleration equals g minus kv squared. Alright, so now the first part here that we're looking at, we're trying to get x in terms of v. So that means that when we start this, we're going to have to use dv on dv on dx equals g minus kv squared. We bring this back down over to here, so it's v on gv squared dv equals 1 dx, and then we integrate this. So we're going to integrate this, and that's going to be from 0 just up to v, and this one's from 0 up to time t. So that'll save us getting the constant. So this is minus a half ln g minus kv squared, because it is the log, and there should be a minus 2 there, 2k actually. So you've got to divide by minus 2k. So divide by minus 1 on 2k, because the derivative of that is minus 2k v. So the minus 2k is missing. And that's going to be from 0 to v. And this is going to be t, and this is going to be from 0 to t. So it's minus 1 on 2k ln g minus kv squared minus 1 on 2k ln g minus 0 equals t minus 0. So we have 1 on 2k ln g minus kv squared equals t. So t is 1 on 2k ln g over g minus kv squared. Which when you look up the top, that's what we've got there. So that's all good. We're all done on that one. Okay, so part B. So part B, I just want to correct something. This should have been x and x and x and x and x. Because if you look back up here, it was x. I don't know how I changed it to time. Okay, so the next one's time. So we're going to go dv on dt equals g minus kv squared. So bring the v down, so you get 1 on g minus kv squared dv equals dt. And this one's definitely t, not x. This is going to be from 0 up to v, and this is going to be from 0 up to t. With this one too, it would have been, yeah, no, I did change that from 0 to x. So this is 0 to t. Alright, so integrating this is a little bit of a pain, really, because it doesn't really follow an easy thing. It's not a log and it's not a tan the minus 1. It's actually an integration by partial fractions. So when you're looking at this, what's best to do, I believe, is to take the k out, because if you take the k out, then it's going to form like something of this form, 1 on a squared minus x squared. And then we've just got to figure out what that actually simplifies to. So it's a minus x and a plus x. So when you simplify it, if you put a plus there and a 1, if you put 1 on 2a, then I think that will actually give it to you. So it's 1 on 2a, and that's a plus a minus x over a squared minus x squared. See how it actually works out. So when you're looking at this, then that's going to be t, and that's going to be from 0 to t, and when you put it in, you just get t. So this is 1 on k, 0. Now I'm going to integrate this. In this question here, a is equal to root g on k. So it's going to be, if we split this up, it's going to be 0 to k of 1 on 2a. So it's 1 on 2 times root g on k. I might go the whole way through and just integrate this part here, because I think that's going to give me a better formula. So it's 1 on a minus x plus 1 on a plus x dx. When you integrate that, you get 1 on 2a. So it's minus ln x, a minus x. So it's a log, the derivative is minus 1, plus ln a plus x. So that's going to end up being 1 on 2a ln a plus x on a minus x. So then I can just put in the a, which is 2 on root g on k, ln root g on k plus x, root g on k minus x. Okay. Alright, so that's going to end up being root k on 2 root g, ln, and if I times this by root k on the top and the bottom, that ends up being root g plus root kx on root g minus root kx, which is what potentially that will be the required result. Okay, so it's not quite the required result, because the required result has v's in it. So I'm just going to change this to v. So it's going to be v's as well. And on the other side, what did I get for the time? It's okay, so the time would be t minus 0, so it's just a positive t. So now I have to make t the subject. So I'll move those over there, and I'll get ln root g plus root kv over root g minus root kv equals 2 root gt over root k. So root g plus root kv over root g minus root kv equals e to the 2 root gt on root k. Lots of fun here. And then we're going to try and get root g plus root kv equals e 2 root gt on root k times root g minus root kv. So we need to get a common, we need to get all the v's together. So it's going to be root g e 2 root gt on root k minus root kv e to the 2 root gt on root k. Bring that over and bring the root g over. So it's root kv plus root kv e to the 2 root g t on root k equals root g e 2 root g t on root k minus root g. So the root g can come out as a common factor, 2 root g t on root k minus 1. And the root kv can come out 1 plus 2 root g t on root k. So v equals root g on root k times root 2 root g t on root k minus 1 on e to the 2 root g t on root k plus 1. So let's just have a look at what we are trying to get to here.